Basically, today we're gonna discuss different topics about the ERC proof of concept. We're going to have like different contributions. So now I will start with overall what is an ERC proof of concept, some tips about how is the evaluation of this, and then I wanted to introduce my previous ERC starting grant, and then how I link the different proof of concepts to this ERC. And then we will have Andres' contribution that he is going to tell us also about his project and some tips. And also we will share with you a link because there is another colleague, Victor Villarraza, also with proof of concept that he has recorded his intervention with some tips. Okay, so let's start. I guess everybody is familiar with starting, consolidator, advanced, and synergy grants. Okay, so this is like the different years that you can apply. Now you know that in 2027, we're gonna change this range a little bit. And then basically, I also, just to mention you that I try to introduce all the questions you provided. So we have tried to put all the information here in this first presentation. So essentially, when can I apply for the proof of concept? So since the very beginning of your starting grant or consolidator or whatever, until 1 year after finishing your grant. Then you can apply, you can get 3 grants per main ERC grant, or 6 in the case of synergy grants. But keep in mind, there are 2 cutoffs, okay, every year, and each PI can only submit 1 proof of concept proposal per call. Okay, so if you go to March and you are in the waiting list or you are just rejected, you cannot apply again in September. But then in the next year, you can do it. And there is no penalization, so there is no constraints, okay, if you don't get it in the previous years. So main points. Basically, this is something that needs to be connected to your previous ERC funding project, so the ones on the top. And then this is lump sum, and this is 150K, and it covers both direct and indirect cost. And the duration now is kind of fixed to 18 months. Okay, so some of you were asking about the TRL. So essentially what they are expecting, or this is basically my impression, is like starting from 2 or 3. So initial validation of a scientific phenomenon. So you have already identified one physical phenomenon or well, in the social science, some aspect that you think that can be relevant. So your fundamental insights, and then they are expecting that you reach 3 to 4, okay? So probably 3, because then you have the EIC transition that is expected to go from 3 to 6. And this is basically user testing, market analysis, IPR, and having what is a proof of concept, right? So the activities that they are expecting is testing and validating ideas from the research you have done previously in your ERC project, exploring commercial or societal applications, clarifying IPR and knowledge transfer. Then I will show you some examples in my projects, and also engaging with potential users, partners, or investors. Okay, so that's kind of the big picture of the proof of concept. Now, evaluation. So this is basically just a screenshot of one of the proof of concept that I was granted. So this is what you are going to see. They will evaluate you in terms of these 3 points, and you need a pass in all of them. So regarding innovation, if what you are proposing have the potential to drive innovation and business inventiveness, okay, and that your solution is distinctive compared to existing solutions. So they want something different, something like with a scientific foundation, but that can bring something new. Then project approach and methodology. So this is basically what you are used to. Essentially, that you have defined your methodology, task, etc. But keep in mind, now it's not only about research questions. Now also you need to pay some attention to demonstrating and validating the idea, that now I will tell you a little bit more about it, and especially all these points. how you are going to clarify the IPR, if you have a clear strategy about patenting, about how you will take your product to the final users. Are you going to do license of use, or you are going to do kind of beta testers that without paying, they will try to use it and validate your technology? If you will try to transfer your patents to a given company, if you are going to create a startup, all of these questions, this is something that they are not asking you to do during the project, but they want you that at the end of the project, you have a clear idea about it. So you need to put here some tasks that are going to be focused on how you are going to do the following steps, okay, until reaching this kind of, well, big picture of where you want to go. And then finally, principal investigator. So to be honest, and I will go later with a specific example, but it's not about telling how good you are. It's more about convincing people that you have the potential to drive this innovation in terms of a product. And also, I will pay much more attention to the management of the project that I will tell you later. Okay, so just to keep in mind, single step evaluation, so there are no interviews. Sole criterion excellent based on these 3 points, and then some success tips. So it's important that you clearly link your idea to the previous ERC funding results. So you get comments related to that from the reviewers, demonstrate potential for real world impact, present a credible and focused implementation plan, and also emphasize your leadership and engagement with stakeholders. Okay, so now before providing you a clear example on what I included and where in my proposal, I think it's important to provide like super briefly a context of my previous ERC starting grant so you can see the links. Okay, so in my grant, I was focused on the role of mechanics in biology. So for example, in wound healing, how are all these forces optimizing or regulating this process? Also, when you have an impact in your head, what is happening in terms of mechanical damage? Why we cannot do or we have cognitive deficits or in tumor progression, etc. And then I identified that there was a current limitation in the state of the art to address all these problems in the lab. So then what I did is creating these materials that can respond magnetically, well, mechanically to external magnetic stimuli. So essentially with this, what we can do is changing the stiffness of the materials or introducing forces or displacement, okay? And then we were using it, okay, to simulate different physiological and pathological processes on different cell types. So for example, here is like cells from the brain that you can see how we can reproduce this impact in your head and see how it's changing the physiological response of these cells. So in the end, this is kind of the idea, okay, of the starting ground. Okay, so now link to the proof of concept and exactly what I did. Okay, so this is kind of the timeline. So I started the starting grant on 2021. Then just to let you know, so first year, after the first year, I already applied for a proof of concept. So this is in yellow because essentially I got well, I was in the waiting list. Then I resubmitted next year. And then essentially in 1 month, I was said that I was granted the new one, but also the previous one that it was in the previous list. So I had to reject one and I started one. So this is one POC that I actually finished, well, last year, well, more or less last year. And then in 2024, I applied for the second proof of concept. Magma did in this case. It was, well, rejected. It was in the waiting list, but it was rejected in the end. And then last year, I applied again for that and get it. And in the meantime, I think this is important that all this proof of concept was essential to create the spin-off that we are running now. So why I'm telling you this? Because I'm going to focus today on the East Biomech, so the one I finished already, telling you more or less all these details. And then at the end, I have collected from both cases, as I have the same proposal, one rejected, one passed, bad comments of reviewers, good comments of reviewers, so you can get this kind of taste of what they are expecting and which are the main criticisms they did. Okay, so this is the idea. So it's biomech. So link to the previous one, the ERC. So this is intelligent device and computational software to control mechanical stress and deformation for biological testing. So essentially, keep this in mind. So in my previous ERC, basically what I was developing was these kind of smart materials that can interact with the biological systems. And also I kind of integrated in my lab to do some experiments. Okay, so you have this first section of the proof of concept that you need to provide the brief description of the idea to be taken to proof of concept. And then you have these 3 points. So the problem, in my case, and this has to be super clear. So in this case, okay, need for in vitro testing methods. It's like, okay, we know that these mechanical effects are important in biology, but how can I test it in my lab? So that's the problem. The solution, okay, I want to have a given product, a given device that I can have in my lab to reproduce it, okay, to impose this mechanical stimuli on the different biological systems. And then what this is quite important also is to link the origin. So how you link it to your previous ERC starting consolidator advanced synergy, okay? And then in this case, it's important that it should be, let's say, close enough, but fun enough also. It cannot be understood that this is just like an extension of your ERC. So it has to be like kind of linked to do something else. And in this case, it's like, okay, so I have already developed my materials and the methods to impose these magnetomechanical conditions. So now what I want to do is developing a product that can be commercialized. Then you have the second part, that this is demonstration of breakthrough innovation potential, that to be honest here, the key point is showing that you have distinctive attributes. The technology, the product, the idea you're providing is different. So this is the example of this project, but in every single project of proof of concept, I do something similar. This is kind of visual table, or it can be a table just with some insights, where basically you need to analyze the different technologies that are there, that are competing with you, and then your technology. And what I try to do is like showing like different attributes and clearly showing what you are providing new. Then demonstration of the high risk, high gain idea. Okay, so to be honest, this is more like the blah, 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 right? That we need to put in our project, but you need to link properly. Then you have this section 1B, that this is approach and methodology. So this is more or less what you are used to, that essentially you need to put like overall how are the different tasks, the different work packages, how they are connected. So here for sure you will have some research-oriented task, okay, that this is as in every single project. But then I wanted to highlight these 3 points that for me were a little bit different, and for me it was the difficult part. Okay, so you need to add task or work package related to the innovation potential and commercialization opportunities. Okay, so of course you will have research activities not only to develop your product, but also research activities oriented to the validation of the product. Then if you're going to do kind of prototype tests and validations, end user involvement type. Okay, so this is important. Now it's not that it's only you in your lab doing your test. I think this is quite important, that you find someone else that is interested in your technology, in your product, in your idea, okay? And you can get them involved. Knowledge transfer also, okay. So all this knowledge that you're going to get, you're going to develop during the POC, how you're going to transfer to that. So you're going to define protocols, user manuals, all these things, and then other stakeholders. So this is okay. After this, what? It's like you don't need to develop a business plan, but you need to, let's say, you don't need a business plan for submitting your POC, but you need that at the end of your POC you have a kind of clear business plan, maybe not totally defined, but you have already identified which are the main points. Then I think it's also important a SWOT analysis with your strengths, weaknesses, opportunities, and threats. Okay. So you are thinking now why your technology or your idea it can be important and it's gonna be easy to take it to the to commercial product or not. And then, well, of course, the description of the methodology. Then you have all your tasks, things you are gonna need, consumables, etc., etc. And then you have this last part that this is related to principal investigator, okay, and strategic lead and project management. So I will show you now, after that, some comments from the reviewers. So in the first one, I talk a lot about me, how good you are, etc., all these things. Okay, so I will recommend like just stating one paragraph about you and maybe more focus on tech transfer and all these things. Okay, because at this point you have already got an ERC, so you have already demonstrated that you are a good scientist, right? So it's more to focus on the project management and technology transfer. And this sometimes is like, okay, what should I include here? So these are the points I have included in the proposal that work. So a management board, okay, it can be people from your lab or some collaborators or some people that are potential users. How you will deal with data management, IP and innovation management. So you have to state, okay, so these are the ideas that I think that can be put into a patent, okay? And then how you're gonna deal with that. You will have the support of your, I don't know, in your institution that there is a kind of service that is gonna help you or how you're gonna deal with that. Then management of risk and contingency measures. And then I usually link because these people from from the innovation part, they like this go no go strategic decision making. So I try to link the last points together. And then some of you were asking about, okay, which support letters do we need? So I just put here, maybe I put a lot, but this is what I put. So I found 3 research potential users, 2 companies that were potentially interested about it, then 1 hospital and 1 institutional. So in my case, I got this Health Start award from Comunidad de Madrid. So in Comunidad de Madrid, for example, we have the Fundación Madrid Más D. So they provide some help and some advising, right, about how to do all this IP and innovation management, etc. So I managed to get a letter from them. Okay, and just to conclude, I have these 2 slides. So first for is biomech. When I submitted the first one, bad comments. So the proposal focuses mainly on explaining the scientific part. It does not tackle possible future exploitation or business opportunities. So, okay, so I think this is the main error that we are all going to make with our first proof of concept, that we are used to address the scientific problems. And here is okay, it's not that much about the science because they assume that it's gonna be okay. Okay, if you have some some errors, of course they will say, but that's the point. Focus a lot on exploitation and business opportunities. Then the analysis of commercial potential is rather very late. So they were telling me, okay, so you are planning to do all the scientific part, and just in the last 1-2 months, starting to think about the commercial potential. So it's told me, okay, so this is something you need to do in parallel from the very beginning. The work plan consists of 3 technical activities and only 1 related to market and exploitation. Okay, so then what I did for the following one was like trying to put some task inside the different work packages linked to that. Lack of visibility to the market size, demand categories of possible customers. It means that you need to add 1 paragraph stating like, okay, so I'm focused on this area. And here there is an opportunity of whatever billion euros, and this is growing and this is doing whatever. Okay, so a couple of comments like that. Okay, risk, this is not saying a lot. Project depends too much on the university technology transfer office. Communication plan is still very generic. Okay. Anyway, when I put this, these are some good comments that I also read because I think it's important to know what they are complaining and what they are evaluating positively. Okay, that it can help you. Very well written, okay, excellent analysis, distinctive attributes of the technology, clearly high risk and high gain. Okay, so this is what I get when I included this table that I saw you, that they evaluated super nicely. Okay, the plan for IPR now, after the comments, okay, now is detailed and very good. Partners appear well integrated into the roadmap. Okay, so this is not only that in the support letters you provide them, but also if you manage to involve these people in some specific activities related to the validation of the product, this is something they really like. Okay, PI demonstrate both technical capacity, comprehensive, effective plan to explore innovation potential. Wow. Okay, and this is just good comments. Second grant, it was a little bit different. It was more related to kind of new diagnostic method. So basically, bad comments. Economic benefits for the intended area, such as tissue engineering, could be argued more in detail. More complete description of societal and economic benefits would have made this section more convincing. Okay, so essentially, you need to provide better statements in the very beginning to motivate how big is the potential market and have a clear link with that. Deliverables are not well defined, minus or comments. Okay, so I didn't put this kind of go, no go, and clear milestone deliverables. Although there are no deliverables, by the way, official deliverables in the proof of concept, but you can have internal ones. Methodology lacks information on how to integrate feedback from end users and stakeholders. So they were saying, okay, so you have your end users, etc., involved, but you haven't provided a clear pathway or method to get information from them and how this information is going to help you. Dissemination not quantified, KPIs are not provided, too little information on data management. Okay, this is important because this point, they changed the rules or this last part, this one, 1C, okay? And now in the last proof of concept, they added this data management, conflict resolution, decision-making processes. So don't forget about it. Last part is not to talk about you, but about these things. Risk analysis focuses mainly on technical aspect. Okay, with no commercial or regulatory consideration. So this is also important. I always forget about it. They're like, okay, you focus on technical risks, but now it's a product. So you can have the best product, but if this is too difficult to use or too different from established things, okay, these are risks. And well, same thing here. And then addressing this, okay, some good comments to finish. Okay, now it was well stated with broader applications. The methodology is well described. The plan is well structured with milestones at both technical and market feasibility levels. So you see that there is kind of coherence between the previous year and this one. So one is like, basically what I want to highlight with that is that if you don't include it, you will have it as a bad thing. If you include it, you will have it as a good thing. IPR strategy is thorough, breakthrough, background IP already protected. So it's important if you have already a patent, put and discuss on this. PI, okay, and the proposal contains detailed risk analysis and credible mitigation measurements. So this is kind of all the stuff I wanted to discuss with you today.